Hey guys, welcome to this session. Our topic is computer networks and communications. Uh, in our past video, we discussed about the network topologies. We saw the concept of topology. We also saw the concept of network topologies. We said there are two types of network topologies. There is the logical topology and the physical topology. So far, we've covered the logical topology. So today, let's discuss the network physical topologies. By starting, we'll see the types of the physical topologies. Now, we have to know that the physical topologies are simply identified is purely by the way in which the networking media connects the devices. So how the networking media connects the devices, you can surely tell the physical topologies that can be used there. Now, a diagram of the physical topology of a network, simply what it does, that it shows the physical path of the media take to reach each of the devices on the network. Now, depending on the requirements, there are different topologies to construct a network. So the following are just the types of the physical topologies. There is mesh topology, star topology, tree topology, bus topology, link topology, and the cellular topology. In this video, we are going to cover three of them: mesh topology, star topology, and lastly, the link topology. We'll start with the mesh topology. Now, in this topology, every device has a dedicated point-to-point link to every other devices. It means that in this mesh topology, every device that is within the network, it has a dedicated point-to-point link. That means it is linked to each other device within the network. Now, the term this dedicated, it means that the link carries traffic only between the two devices it connects, not further away from that. Now, to connect the nodes in this mesh topology, we require a duplex mod links of a form like this. That is n in bracket n minus 1 upon 2. Now, one practical example of a mesh topology is just a connection of a telephone region office in which region offices needs to be connected to every other region office. So here is just an illustration of this mesh topology. As you can see, every connected device is linked to each other, as you can see throughout the network. Moving on, the second one is star topology. Now, in this star topology, each device has a dedicated point-to-point link only to a central controller that is called a hub, or it can either be a switch. Now, the devices simply they are not directly connected to one another. Unlike the mesh topology, a star topology does not allow directly this traffic between devices. The controller acts as an exchanger. So the controller, what it does, maybe if one device wants to send data to another, it sends the data to the controller, which then it relays the data to the other connected device. As you can see, here is just illustration of this star topology. Here is the controller. So if this device wants to send the data to the other device, it will have to relay the device it will have to relay the data to the switch or the hub, which is the controller, and then the switch or the controller will just send the data to the needed device. The same goes to all the devices throughout this kind of a topology. Moving on, last but not least, we'll discuss about the link topology in this video. Now, in this link topology, each device has a dedicated point-to-point connection with only the two devices on either side of it. So a signal is passed along a link in one direction from device to device until it reaches its destination. Now, each device in this, the link, it incorporates a repeater, whereby when a device receives a signal intended for another device, simply what it does is that its repeater regenerates the bytes and passes them along. Now, a link is relatively easy to install and reconfigure. as compared to the other topologies. Now, each device is linked to only its immediate neighbors, who are the closest one, either physical or logical. Now, if you want to add or delete a device, you require changing only the two connections. Now, the only constraints are the media and the traffic considerations, that is the maximum link length and the number of the devices. In addition, also, the fault isolation is also simplified. Generally, in a link, a signal is circulating at all the times. Now, if one device, take an example, it does not receive a signal within a specified period, it can issue an alarm. Now, the issued alarm alerts the network operator that there is a problem and its operation. However, maybe any directional traffic can be disadvantageous, since that in a simple link, a break in the link such as a disabled station can disable the entire network. So this kind of a weakness can be solved by using a dual link or a switch capable of closing off the break to ensure a continuous flow throughout the topology. So this is just a simple illustration of how a link topology, how it is and how it works. So that's all about this link topology. So I hope it's clear, guys. Thank you for listening. We've seen the various typical types and the various kinds of the network physical topologies. We have said that there are 6 of them. In this video, we've covered 3 of them, and the other 3 we'll finish them in our next videos. Thank you.